This is the 2005 Form B FRQ from Calculus AB, number 1. We're doing part C. To do part C, though, we need to find the intersection points. So how would you show finding intersection points? I'm going to show you a few ways you can write this. You could say f of x equals g of x. That would give you a point. Or instead, you could write the actual functions. 1 plus sine 2x equals e to the x over 2. Or a third option, you could do a pre-statement on your paper, has to be on your paper, and say, let y1 equal f of x and let y2 equal g of x. So now you've made that f of x and that g of x. And why did I choose y1 and y2 again? Because in my calculator, that's my y1. In my calculator, that's my y2. So you could even, after writing this statement, you could have written y1 equals y2. So any one of these three statements would have given you a point. But again, to use this, you have to define y1 and y2. You can't just assume y1 and y2. Then you would say at and where they occur. So you go to your calculator and you plug those in. And then you calculate the intersection points. So how do I calculate intersection? I do my second function, trace to calculate. And I want to calculate intersection. So I'm going to hit 5. And it asks you, what's your first curve? Is it the blue one? Yes, so I enter. Is the second curve the red one? Yes, I hit enter. I'm going to guess. You can move the blinky bob close, or you can enter a value. It looks like 0 to me. So I'm going to guess 0. That's my guess. And hit enter. Bam. It was 0. 0, 0. So that's easy. I could say at A equals 0 and B equals. And if you want to, on the picture, put an A and B here so you know what they represent. I'm not going to store 0 on my calculator. I know 0. I don't have to store it. But the B one, I'm probably going to store that. So let's find the other intersection. So I will go, uh-oh, did my battery die? Oh no, I think my battery just died. It did. All right, let me turn it off and on and see what happens. Let me try this. Did my battery die or did something else happen? Yeah, I don't know what's going on. I think oh, there it is. It's back. It's back. Okay, so I want to do second calc intersect, so 5. And is my first curve the blue one? Yes, enter. Is my second curve the red one? Yes, enter. I'm going to guess. To me, it looks like 1 point something. So I'm going to guess 1. So I'm going to hit 1 and enter. And it comes out to be that number there. I'm going to store that number. So I'm going to go to home screen by doing second quit and say, hey, calculator, take what's in X and store that as, and I'm going to save it as B, alpha B. That number stored, 1.13569, 13569, 13569, 1. I forgot already.
13965.
1356925. 13 something 9625. 1356925. Oh, 6925. Yeah. So you would get a point for finding the intersection points. So 1 point, 1 point. Now you know the coordinates here. And for my own good, it's b comma something. And the coordinates here is 0 comma something. I could plug it in and get that 1. You don't have to. And you could plug in. No, we're not going to do that. You could find this, but we don't need it. Okay, so we're doing part C. The region R is the base of a solid. The cross sections perpendicular to the x-axis are semicircles. So I'm perpendicular to the x-axis. Here's the x-axis, so perpendicular to that, it's this way. So these are the base of the semicircles. The base of the semicircles go this direction. Let me zoom in. Let me make it a little thinner. That's the base of my semicircle. Now the semicircles, I probably should write that on the other side. It's hard to see, but you have to kind of look at the videos and be comfortable with it. But the semicircles are kind of going to be like this, coming out at you. And so we're going to find B, okay? So down here, I'm going to say B is big Y minus small y. So what's big Y? Big Y is f of x. Small y is g of x. So you could write f of x minus g of x, or you could have said y2 minus y1, right? Or, I'm out of room. Or you could have actually written the functions. 1 plus sine 2x minus e to the x over 2. So you could have written it out also. Any of those three gives you b. But now let's do this. The volume of our solid, I add up all of the half circles. Now you should see that they're stacking horizontally this way. So my first one's at 0, my last one's at b. So I would go from 0 to b and add those up. You would get 1 point for that. Okay, I probably shouldn't have done that yet. Let me wait till I get the final. So you know it's the area of the shape times the thickness, and the thickness here is left and right. That's a change in x. So that thickness will be dx. But what's the area of a half circle? Area of a half circle is pi r squared over 2. That's the area. And here's where you need to be careful, because a lot of people make mistakes on the semicircles. I can pretty much guarantee you, you are going to have a semicircle that you're going to have to do on the test in a couple of weeks. So you're going to have one. So being organized makes you make less mistakes. So I'm going to pull the pi over 2 out because that's a constant. Now, if we can figure out r, we are done. And I think this is when people start memorizing, they start confusing this 2 with this next 2 we're going to have. But what is r? Now, here's what's sad. R has already been used. And then I'm going to use another r that's different. That r is different than this r. That's the region. So I'm going to use little r1 for radius instead of big R. So just be careful about variables and things. What is R1? Now, I'm going to lower all this stuff. So what is my R1? If you look at this picture, this base is not the radius. That is not the radius. The radius is half this base. The radius is the base divided by 2. Now, you could have any one of these over 2 for your radius. You could have f of x minus g of x over 2, or y2 minus y1 over 2, or, I'm not going to write the last one, this over 2. Any one of those. Now, here's what's kind of cool to make your life easier. I have, well, R1 is this. You could write that here, but you don't have to. Once you define R1 to be this, when you put R1 here, essentially you put that here. Or this is there. If you write this on your page, you don't have to replace R1 with this or this. They are all equivalent. You don't have to. If you choose to, you may, but here's the problem that people run into. They'll say R1, okay, I know what that is. That's going to be f of x minus g of x over 2 squared. And then they start doing some weird stuff. They'll pull this 2 out in front and make that a 4, but that 2 is being squared. So if you're going to do it this way, put this in your calculator, okay? Honestly, here's what I would do so I don't make a mistake. I'm going to make my y3 equal to r. Watch this. I'm going to go to y equals. I'm going to scroll down to y3. I'm going to make that my r. How am I going to do that? It's going to be, I'm going to make a fraction. And on top, I'm going to go alpha trace y1 minus alpha trace y2 over 2. That's my r, right? It's y1 minus y2 over 2. That is my r. So if I know my y3 is my r, I'm going to go ahead and quit. Now watch this. At this point on the quiz, I would give you 1 point for knowing you integrate from 0 to b. Let me circle these or box these. There's your 1 point. I might even give you a point for knowing that it's pi r squared over 2, so that pi over 2 constant. Then I would give you a point. Whoa, this thing has a mind of its own. For having that. And then 1 point for the answer. But to get that answer, you're just going to have to pop that in your calculator. And here's what's beautiful. Watch. I'm just going to pop that in the calculator. Pi over 2 integral. So I would do this. Let's get a fraction. On top is going to be pi. On the bottom is going to be 2. And then I'm going to math 9 to integrate. I know it's 0 to b. Alpha b. Whoa. Whoa, 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 what'd I do? I don't know what I did. So I want to put r squared. My r was alpha y3. Look how easy that is. And I square that. So that's why if you put your r as a y value, your integral is so easy to write out and you don't make dumb mistakes. That's why I like the way I'm doing it here. You get, whoa, 0.077 or 0.078. You can round off or truncate. So you could chop off any number after 3 decimal places, 0.77, or that 6 turns that 7 into an 8. Either answer, or you can write this whole thing out. You must have a minimum of 3 decimal places or 3 points, 3 numbers after the decimal point, minimum. If you write less than that, I'm taking points off. There's a minimum of 3 required on the AP test. And I recommend just leaving 3. Honestly, what if you write out the whole thing and this 8 should have been a 7 or the 6 should have been a 7 for some weird reason? You may lose that point. So rounding off to 3 is probably the safer bet. But if you don't remember how many places after the decimal, I would not round off if you weren't sure. So the answer, you should put a squiggly because we are rounding off. It doesn't equal, it's approximately equal to. I would put 0.077, or if you round off 0.078, I would give you 1 point for the answer. And that's the breakdown of this problem.